So welcome to this structural exam video. I'm delighted to have here David Brohn, Dr. David Brohn from New Paradigms Ltd. You may know him from his Understanding Structural Behaviours course. And it's an honor to have him here with us, chatting away. And we're going to be asking him about what makes a good engineer in general and how people can improve themselves, how graduates can improve their career prospects and get themselves a head start. So, hi David.
Hi.
Aside from the introduction that I just gave, would you like to introduce yourself in any way?
Sure, yeah, sure. Okay. Yes, I've been thinking about this because we've been talking about doing this interview for some time. And my sort of peak professional experience, but it was when I was young, was working for the Ovara Partnership in London on the design of Sydney Opera House shells. And it was particularly significant because I knew I was working with the best brains probably in the world. And it was interesting to see such a complex job going through the process that it did. But looking back on that time, the thing about it was the impressive engineering skills that were around me. So Ted Happel was on the same floor. Ian Liddell, who went on to be a partner with Burra Happold, he's a contemporary of mine. But the most interesting person was Jack Zuns, who was their South African partner and came back to England to run Sydney. And the thing about Jack, and he was a wonderfully approachable person, and he had a couple of difficult problems which he brought back from South Africa. And I can remember looking at one and thinking, just so complicated. I have no idea how you solve that. But to him, it wasn't complicated at all. And the essence of being a good engineer, and I guess this applies to any discipline or any profession, is that you've got good judgment. You know when it's complex, or you know when it's simple, and that judgment comes from a great deal of experience. So my background really is in the teaching of and understanding of structural behaviour, which all started with a testing of the Arup graduates. And Arups then commissioned me to develop a two-day training course, and it's that two-day training course that I've been running ever since then. So I get to talk to very senior engineers, many of whom did my course sort of decades ago and now have brought me in to teach their graduates. And they are increasingly concerned about the poor understanding of the basics in graduates. And so I address that to some extent in my course. And what we're looking for is what were the skills that you would introduce to young engineers so that when they become increasingly experienced, their judgment increases as well. And I guess it has to do with really understanding what's happening with the structure, because we have an unusual discipline. And unlike mechanical and electrical engineering, we never prototype. So the truth is we don't actually have any idea what the factor of safety is on the building. And so we need a really exceptional attention being paid to the modeling process. So structural engineering now is all about the modeling. Forget about the analysis, that's all done on the computer. We don't really need to be taught that, but we need to be taught to develop our judgment and understanding, and that's an open question as to how we proceed with that.
When you were in Arup and then when they commissioned you to do this, because obviously you'd already shown some aptitude towards training people up, but was it a real problem that they needed solving immediately?
No, far from it. No, far from it. The background is that after Arups, I went up to Leeds University where I did postgrad and my doctorate, and came down to Bristol and worked for a small firm there for 5-6 years. And it was very boring after working for Arups, and I decided that I'd become an academic. And Bristol Polytechnic, now the University of West of England, was just formed. And so I went there as an associate partner from the firm I've been working for. So I was quite an experienced designer and used to the situation of talking to the client and the architect and trying to arrive at a structure. So the first class I had at Bristol was preparing people for the charter membership examination. And my background's in reinforced concrete, so we chose a reinforced concrete question, sorted out a frame. I sketched the frame and said, okay, stick some loads on that and let's get the bending moment diagram, and then we can start sizing the structural members. And they couldn't do it. And I tried a couple of other groups I was teaching and they couldn't do it either. And I happened to be at IStructE at some meeting, and the man who'd interviewed me when I first went there was Peter Dunnican, who's the managing director. And he was there at this meeting, and I mentioned I'd got this problem. And he said, what do you mean? So I showed him a test I devised, two-dimensional frame, 22-dimensional frames, but a qualitative solution. And I said, you know, my students are having difficulty solving these problems. Would your graduates be able to solve them? And I can remember he looked at me absolutely pitying, you know, what are you talking about? We employ the best brains in the world. Of course, these problems are trivial. I said, well, okay, I wouldn't put Bristol Polytechnic in the best brains in the world, so maybe that's what the issue is. And then, and looking back over a long career in this business, there are certain days which changed my life, and this was one of them. And I said, can I test them? And Peter Dunnican, I think, had a similar background to me. He didn't do, I haven't got a first degree, and he didn't have a first degree. And I think he got fed up with academics looking down their nose at him. And he said, yeah, I suppose so, yeah. I said, what sort of score do you think they'll get? Oh, 90, 100%, yeah. Now, they took in about 200 grads each year, very large group. I was a very inexperienced academic, and I hadn't realized how significant it was to get hold of a group of people and test them that you hadn't taught. So I gave them the test, score came out, 37%. Oh, really? Oh. Well, said Peter, it's your test. I said, what are you talking about? It's just lines on a piece of, no, he said, that's it, because we know they can do it. We know they can. So, okay. Come back next year, same result. Oh. Yes, you see, you're testing them in September, but they graduated in June. I said, hold on a minute. I'm not asking them to remember some complicated formula. I'm saying, here's a structure, stick a load on it. What happens to it? He said, no, that's definitely it. Because we know they can do it. Yeah. Okay, so I come back next year. Yeah, okay. I came back next year, tested them, same result, and then I gave them the results of the test, came back 2 weeks later and tested them again, same result. So now we know they can't do it. I don't know why they can't do it. Nobody else knows why they can't do it. And so I said to Peter, look, it's not fair of me to come into this group of acknowledged, exceptionally bright young engineers and say, here's a test, you failed, goodbye. And so I asked them then to commission me to develop a training course to correct this deficiency. I did. I taught it at IStructE for several years, and I've taught it ever since.
Wow, and it's carried you through the last 30, 40, 50 years of teaching.
Well, I've done it and while I was doing other things, as I ran a software company from 86 to 96, and various other bits and pieces. But eventually in 2006, I decided I'd focus exclusively on training courses. And that coincided with the institutional structural engineers setting up their own CPD department. And I was one of the lecturers who ran courses for them, yeah, and still do.
If you have a piece of paper there, would you mind just giving us a sample, a quick snippet of one of your questions that you were asking these graduates?
Yes. Should I do this on paper, Tim? I'm
sorry, do it on paper and just hold it up to the camera.
Yeah,
that's
okay.
Fine.
So this is where it all started, with this statically determinate frame, item 13 in my test. And that solution is the one given by 90% of all graduates I've ever tested. Now, the interesting thing about it is that, first of all, it's statically determinate. So you could, if you like, stick some numbers in there and calculate it. But they don't do that. They do try to solve it. But it should be immediately apparent that it's incorrect.
I can see where it's incorrect already. Yeah.
Because the bending moment on the column requires a horizontal reaction. The balancing horizontal reaction would cause a bending moment of the hinge. Therefore, that solution is incorrect. And that is the essence of the skill that I try to teach on my course, because all of their education instructional analysis in an undergraduate course has been about identifying linear algorithms. The problem is you can't apply that type of thinking to my problems. You have to be able to sort of go around in circles and test your solution against other parts of the problem. And they don't do that. They don't know how to do that. And that's what we spend 2 days doing.
Are there any advantages or disadvantages to doing this kind of, like as you described, the circular, more iterative approach? Let's call it the Brohn technique.
The Brohn technique, yeah. Well, I think I've run this course for some of the world's leading firms of consulting engineers. Bura-Happold, Robert Bird, Ecom, Atkins, and I go back year after year. And I think the reason why they like it is, first of all, this understanding of structural behavior is what I describe as the alphabet and grammar of a full understanding of the structural behavior. Of course, most of the problems they face are not simple two-dimensional frames. But if you can't solve these problems, then you don't have that understanding. It's as simple as that. And so it's a good place to start. But they also recognize, my employers also recognize, that this type of circular thinking exactly mimics the real structural design. So when you start trying to solve and create a structure, you don't know where to start. You don't know how high it is, how heavy it is, or what the loads are, or anything about it. And so you can't apply a structural theory to creating the structure. You can only start with an understanding of structural behavior.
Thinking of an undergraduate straight out of A-levels and joining university, first day of their first degree, at what point or how long would it take them to develop a sufficient intuition to be able to solve things the way you do it?
Yeah, that's the problem. The explanation for this comes from a book by a man called Thomas Kuhn, K-U-H-N. The book is called The Structure of Scientific Revolutions. And he was the philosopher of science, that's his discipline, who developed the term paradigm shift. So up until his book, it was believed that science change was incremental. He demonstrated that actually change in science is extremely rapid over a short period. And the classic one he gives is the change from a geocentric view of astronomy, which the whole world thought for 2,000 years until the middle of the 16th century. And then Copernicus and Kepler fell out of bed one day and said, no, it goes around the sun. And that was a massive change in scientific belief. And that was a paradigm shift. And we've just been through a paradigm shift because prior to the 1990s, all calculations were done by hand in the design office. And unless it was a very unusual problem and you had an exceptional analyst, then the only method you had was moment distribution. And the only thing that worked with was two-dimensional frames. So it's no wonder that all the buildings of that sort of period, particularly the 60s, were so boring and rectilinear. Then, 1992, Windows produced the first stable version of Windows 3.1. And at that point, everybody, because I was a software developer at the time, everybody jumped in to use that as the development platform. And literally overnight, within a period of 10, 15 years, there was a desktop computer with the most powerful analysis software in the world. Now, before the computer, you had to spend a lot of time modeling it because you didn't have any tools that would tell you how to analyze a very complex structure. You had to make it simple enough to analyze. Now you can analyze anything you like, and your client knows that too. So there should be a completely different teaching strategy to anticipate a design office where nobody does any detailed analysis. But that requires such a dramatic shift in the syllabus that it doesn't really happen. So I don't, although if you picked up a syllabus from every university in the world in structural engineering, for the subject of structural analysis, it would say the student shall have a sound understanding of structural behavior. The problem is, everybody thinks that's something different. Nobody's got a fixed idea. And it wasn't until I came along and said, look, I'm going to tell you what it is. It's the ability to solve these two-dimensional frames qualitatively. And I confidently expected somebody else to come along and say, no, no, you're not right, it's this. But nobody ever did. So that has become the sort of standard method of testing. And now the Institution of Structural Engineers has their own test for understanding structural behavior. So it's risen up the importance in the discipline. But I don't think that undergraduate study prepares them at all, because the mean score, because I test every group I teach, the mean score hovers around about 25–30%. And that's for companies who focus on structural engineering, like Prehandover. If I pick the average punter from a civil engineering degree, you would not believe, looking at the test results, that they actually knew what a bending moment was. Now, part of the problem here is that undergraduate courses have been stuffed with a whole lot of subjects, which I think is completely irrelevant. Why would you teach management to a group of students who can't get out of bed in time to go to a lecture at 9 o'clock? Why teach health and safety? It's not an academic subject. You just go away on a weekend course and learn it, or buy the books or whatever. So there's a lot of stuff in there which has obscured the core subjects, which should be analysis and design.
As the modern workforce is much more not just adept with computers, but because processing power has become so cheap relative to 50 years ago or 40 years ago, are you able to quantify, for instance, these test results, how they've changed over time, or has it remained quite static?
The test results have got steadily worse. The only group of students that I ever tested who performed well were in Hong Kong. And before I got there, when I got there, I talked to the lecturer who taught before me, because they did a 4-year course at that time. So they were directly equivalent to what was then the 3-year graduate course in the UK. And I showed him the test, and I said, your student, I'm going to test your students, do you think they'll be able to solve these problems? He said, oh yes, absolutely. So I said, why? He said, because that's what I teach them to do. Now, they produce a score of over 60%, mean score. Best group of any I've taught. And so there are cultures that, did, I mean, that was a long time ago. More recently, I went to the Havel's Warsaw office and ran my course there. And actually, they didn't need anything. They were very good, very hot. And so culturally, it looks as though there's 1 or 2 universities in Poland who pursue this approach.
It's interesting you mentioned Hong Kong, because they have one of the highest chartered member exam number of candidates across the world. But they also seemingly perform worse than the UK graduates.
Yeah, I know.
So why is there... we're going to speculate, but I guess there's no way we can prove the answer, but why do you think there could be this disparity?
When I was teaching in Hong Kong, after a month, I realized that nobody had asked me a question. So I said to the Chinese lecturer that I got friendly with by that time, who'd done the teaching before, I said, why don't they ever ask me a question? He says, they can't, because they will make you lose face. because it means if they have to ask the question that you haven't taught them properly. I thought, wow, that's a real cultural issue there, because it means you can't challenge the older profession. And I think that, I don't know, this is very superficial because I have never studied it, but I got the impression that they found it difficulty. They were very good at analysis, very good at the mathematics, but their judgment didn't seem to have much development. And I think that's the reason why they find the charter membership examination so difficult. They're not taught to think in the round. Their culture is about following a predetermined and creditable route. And that works at an undergraduate level, but not for our sort of exam.
When you went to teach the Hong Kong group and did the test for the first time, was this the pre-handover or post-handover period?
Oh no, this is a long time ago, late 1970s.
Okay, so pre-handover.
So it was a colony, yeah, at that time.
Yeah. Because I don't really know much about the Hong Kong education system, but have you ever noticed any differences in, for instance, the Hong Kong graduate results since Chinese handover?
It's relatively rare for me to test a student from Hong Kong who has not gone to a UK university.
Right. Okay.
Almost exclusively they've studied here. So the numbers would be so small, I wouldn't be able to draw any conclusions.
Thinking about the traditional methods of teaching, because I guess I'm quite privileged to have studied under, I guess, one of your disciples, Professor Timibel at Bath. He is very strongly advocating your methods of teaching.
I think he'd prefer colleague rather than disciple. But yes, I mean, Tim, I lived in France for 5 years, came back in 2014, and he was one of the people I contacted because I wanted to find out what the current view was. And it was startling, our measure of agreement. It was very encouraging and really quite extraordinary. So yes, he does think it's a good idea, but there's an issue in the academic world, and that is, well, it's not an issue, but it's what you need to understand, and that is that academics are independent. You can't tell an academic what to think, or actually what to teach. You've appointed them to teach on the basis of their experience, and they'll go on doing that. And so I think even Tim has had some difficulty in getting people to follow these ideas. So it requires, funny enough, it requires, if this is important, and it now is as far as the Institution of Structural Engineers is concerned, then they should be influencing the universities to change what they teach. It won't come from anywhere else.
When you see these attendees on your course, do you notice like a light bulb moment when everything's like, the fog has lifted, or is it more of a gradual kind of process?
Yes, it is. I remember one occasion, and it really stuck in my mind. I think it was a course I was running for the institution, and there was happened to be a young woman. I mean, that's coincidental, but she was very clever, very bright, working at the absolute top end of analytical methods for a very impressive company. And at the end of the first day, which is we've spent looking at beams, the behavior of beams, she came and said, is it going to be more difficult tomorrow? I said, yes, it is, I'm afraid, because we go on to frames then and introduce horizontal displacements and forces and so on. And she was, shattered. And I think the reason there is that she was an exceptional linear thinker, and she found it very difficult to let go of that. And so the light bulb moment is when people realize that there isn't a method that will solve the problem. It seems a bit unfair, since that, in a sense, is what I'm teaching them to do. The point is, my method doesn't have a method. You actually have to understand it. You have to understand the relationship between what I call the three-part solution: deflected shape, reactions, Benny moment diagram. And so the one thing that is clearly missing from undergraduate study is being able to draw the deflected shape. without all the other parts of the solution. I give everybody a piece of nice flexible plastic, and then you can very easily simulate a fixed end and supports, and they, for the first, that is the light bulb moment. For the first time, they see that the deflected shape gives them other information, because if it's doing that, it means that there's a moment in that direction. So that's the light bulb moment. But not everybody gets it.
So maybe for everyone listening or watching in on this video, like if you can carve yourself out a piece of
plastic. Get a piece of plastic. Yeah.
So something like a 30-centimeter ruler.
The ruler's okay. They're unfortunately they're a bit too stiff. They're a bit too thick, a bit too wide. You do need a bit of.
How long is your one there, roughly?
It's 30 centimeters.
Okay, so yeah, maybe.
You can buy this stuff you can get this from modeling shops. That's where I buy it in. I don't know why, but it has to come from America. Anybody who wants it, just get in touch with me. I'll tell them where to get it from, but I have to get it from a modeling shop.
I mean, I imagine most viewers will be thinking, yeah, but I'm clever enough to do this. I must be linear, so I must be one of these more rounded individuals. So like, are there any characteristics that you can think of right now that people can try and evaluate themselves to see which side of that divide they fall into?
Yes, that is a good point. This is a bit off the wall, but I advise people to do the Myers-Briggs personality type indicator. And this is a test. It's a questionnaire developed by an American mother and daughter, actually, a long time ago, I think about 1930s, 40s. They decided that people chose a different way of thinking. And it was only after Jung's book, because he'd written a book called Personality Types, which was exactly their thinking, but had never been published in English. And so they were busy developing exactly what Jung had developed, except they added a fourth component. And basically what it does is it tells you whether you're an introvert, extrovert, sensate, intuitive, feeling or thinking, judging or perceiving. Now, as an engineer, when I was young, I thought I ought to be good at motor cars. So I'd try to replace the brake pads on my car, for example, and I'd have enough bits left over to do another one. And I'm absolutely hopeless at anything to do with cars. So when I was tested, I come out INTJ, which means I'm an introvert, intuitive, but that's the end bit, thinking, judger. And judger means, you have to read around it a bit to understand what these things mean. But the first thing to say is it doesn't mean that you're any good at it. So although my intuitive score was very high, I know lots of other people who are very high intuitives and they make the most worst decisions in the world. So it's not a quality, it's a preference. It's what you prefer to think. And there seems to be a correlation between that and graphical imaging, between intuition and graphical imaging. And it is more an artistic skill than it is an analytical skill. And that's really the issue. And it's connected to the left hand, right-hand side of the brain, connected to the left hand. 25% of all those who attend an art school are left-handed. The mean score for the population is 8%. So there's something in there about how you develop this different way of thinking. But what I say on the course is what you have is practice, because all around you, every time you walk down the street, you'll see half a dozen structures. Street furniture, scaffolding, buildings being built. And in every case, you should look at them critically and think, how is that working? You know, why have they done it? Blah, blah, blah. So it's all there. And I ran a course recently where two of the people on the course were exceptionally good, a very high score. And they happened that they both came from Greece. And I thought, oh, that's interesting. Maybe that's the approach they take in the universities in Greece. But when I talked to them, it wasn't that at all. What it was that for some reason or other, they just got very interested. I don't know whether they had my book or whatever, but they just decided that they wanted to be able to solve these problems. So they taught themselves.
Wow. And it's funny that you mention, well, the MBTI, so Myers-Briggs type indicator, but also the creative side of it, because now I can't remember the reference, but I seem to remember somewhere along the line, people who are very good at mathematics and physics, the ones who excelled the most were also very good at music and creative arts and things like that. I wonder if this is connected somehow to this.
Yeah, I mean, who knows, Tim, really? I mean, yeah, I don't like speculating in areas in which I'm completely ignorant. So there's something to be discovered there. There is a correlation. And my guess, as I say, that I think it's a right brain skill, because the right brain processes graphics. And it's the Chinese have to be able to recognize 3,000 ideograms to read a daily newspaper.
I can attest it's a lot more than that.
So I don't know the answer to it.
So thoughts about those who do your course then. So do you see a transformative, or do you see a transformed customer by the time, for 1.5 days, 2 days after starting your course? Do they feel more confident? Do they?
Yeah, I'm sure they do. I'm sure that I wouldn't be called back year after year to these major practices if it didn't have a direct effect. So yes, I've had a number of people give me references of how pleased they were and changed their life, and all that sort of stuff. So yes, I wouldn't be doing it now actually if I didn't think it was transformative. It would be too depressing, really. So yes, I do know that it works. And I come home and then something. My partner says, "How did it go?" I said, "Oh, usual stuff. Carried shoulder high with Vestal virgins spreading oak leaves in my path." So sometimes it's partly to do with the size of the group, actually. If you get a group of around about 15 or 16, you get a great energy going. If it's 7 or 8, it's terrible. So if it's a really good group, they are really thrilled silly to have done the course at the end. Yeah, I can say that with confidence.
I mean, so for those who either might not be able to attend one of your courses anytime soon, I mean, we're also in lockdown right now. What can they do to help themselves until they can attend one of your courses?
I said I started to do this full time in 2006. And in 2008, I went to Los Angeles, New York, Warsaw, Bath, and London a couple of times for Burapple, running the course, and other clients. And I didn't have time to pack in between. I thought, this is ridiculous. So I thought, there's a demand here. I'll find if there's a way of putting it online. And that's what I started, which neatly coincided with the 2009 commercial collapse. And so everybody canceled all their training budgets. But that gave me the time to work it out. And I did it in collaboration with the Institute of Structural Engineers. And we launched my online system in 2011. And that has 3 courses: Understanding Structural Behaviour, Understanding Structural Design, and Understanding Structural Analysis, and a couple of other courses as well. Those are the 3 that I wrote. And at the time, there wasn't a delivery system that seemed to me to work. So I wrote my own delivery system, and we're just about to release a new version. So the answer is that I have sold my course online all over the world. It's something, it's humbling in a way. And I get an order from, the middle of Bahrain or the middle of Malaysia or something like that. I think, where do they find out about it? Well, of course they do. A lot of them are student members of the institution, so I guess they find out that way. So the answer is you can do it online. And what I'm doing now, partly because of the lockdown, is that I'm offering my online clients a monthly seminar, a webinar on Zoom. And I will announce that on the dates on the website.
Yeah, and we'll make sure to link to your website in the show notes as well. So and everything else that we've mentioned, all the books and everything. And are there any individual cases where you've felt like you took enormous personal pride out of that one person's success, or just a testimonial that you received, or anything like that just kind of stands out?
A quite remarkable testimonial, quite remarkable. Completely out of the blue, came a few weeks ago. And it was so impressive. I redesigned the back cover of my textbook and putting it on there. And it was somebody who had done the first course that I ran at Arab. And he then joined, after working for Arabs, he then joined a small practice and bought out the other partners. And he now runs 4 offices in the north of England and in Scotland. And his letter to me was just lyrical, you know. I mean, as far as anybody reading could see, I'd completely changed his life. And he taught all of the people he employed the same method as my method. Everybody's got the textbook and so on. So there are quite a few. If you look at the reviews on Amazon of my book, they're very telling. And the people who've written those reviews have got the message. Because what I'm saying basically is, stop using the computer. Only use it once you're absolutely sure that you've got the right model. And you don't get that model without an understanding of structural behavior. But I'm afraid that a lot of graduates use the computer as an alternative to understanding. And that's very dangerous, because computers are fast, but they're stupid. And we're the only people who actually know anything about engineering. And that's the side of our lives we need to develop.
Drawing to a close, I mean, a lot of viewers of the Structural Exams YouTube channel will have seen that I've been doing a lot of these understanding structural behavior type videos lately. I imagine then, if people can get a good grasp of that, they should be, and if they can supplement it with your course, they should be ready to tackle any problem thrown at them.
They will be a lot better equipped, yeah.
Do you think we should devise a little test for them then? Say another 20 questions. I think that'd be quite fun.
I don't think it works, Tim, because I was approached by one of the country's leading firms consultants asking whether I'd run a course for them. So they said, what do you do? So I said, well, basically, you know, get them to solve qualitative Benny moment diagrams. And he said, oh, we don't need that. No, all of our employees are very good at that. So I said, okay, well, look, just humor me. I'll send you 4 examples. So I chose the ones, of course, that nobody ever got right in the test, sent them off to him. And I rang him up a couple of weeks later. I said, how'd they get on? He said, oh, yeah, they've got them all right, yeah. So I said, how did they do that? He said, they put them on the computer. I thought, right. We are not talking from the same, we're not singing from the same hymn book here. We've just got a different, so, you know, I've met people, I remember giving a talk to academics once, and I could see a look of sort of, what is this boring old fart going on about? And he said, don't you understand? We've got computers now to do this. And there's a point of principle here, and it's about understanding before you use a computer. And most of the big practices would require their young entities to do that. But just on a final point on this business of structural modeling, that is what has come out of recent courses, that they have no idea whether the model that they have ended up with is valid or not. And there isn't a test. That's the point. If your understanding is poor, you can arrive at a model, but it's the wrong one.
Wasn't there a SCOS report recently, or maybe in the last decade, someone had basically modeled the wrong thing?
Yes, SCOS is full of, that's the Standing Committee on Structural Safety. Yeah, I mean, regularly, every month, I think, there's an example of misuse of computers. My favorite is consultant in the Midlands who was working with a BIM model. And they issued the drawings to the site, reinforced concrete frame, 8 stories or something. And the contractor built the foundations, columns, and the first floor, and then noticed that the first floor was spanning 14 meters with a 225 millimeter slab. So he went back to the consultant and said, "Look, this doesn't look right. Are you sure you got the right stuff here?" And it turned out that someone had deleted 6 columns from the BIM model. So they never got to the site. Now, when he was asked how this could have happened, he said, it's the fault of the software. And I think what he meant was that if you're going to do something as drastic as removing 6 columns from a structural model, you would think that the message would flag up with, are you sure you want to do this? But BIM is a very recent development. It's not very sophisticated in that respect. So there isn't a message. You delete what you like. So yes, there's good opportunity for the misuse of computers all the time.
Yeah. Well, I mean, it scares me, honestly. And I can also see it. I can see it from the structural exam customers who come, who've basically sat behind a computer and only analysed via a computer their whole graduate career so far. So yeah, I'll definitely. I mean, I have seen some of David's material before. I haven't been on the course before, but I can definitely attest to just how much of a paradigm shift, as you say, it is, and definitely recommend it to all structural exam customers, and not just that, but anyone thinking of taking the chartered member exam with the IStructE. And not only just is it more likely to help you pass, I mean, that's quite a bold claim, but it also just helps you become a better structural engineer in general. And ultimately, I think that's what the world needs.
Yes. I mean, if the charter membership exam required people to create and solve very large, complex theorems, then this wouldn't be. But they don't. They just want some freehand sketches of a structure that's going to stand up. That's how you pass the exam.
Mm. Well, on that bombshell then, I'll draw this interview to a close. So thank you very much, Dr. David Brohn, for being on this show. And I hope that you get a lot more customers soon out of this.
Okay. Thanks a lot, Tim. That was very interesting. Thank you.